Good morning, everyone, and welcome to another episode of Constellation Crew. I am here with my crew members, Madeline and Caleb. Say hi, guys.
What's up, y'all?
Hello. Hello there. it is almost May the 4th, so.
Oh my gosh, yes.
You got like 2 weeks, Caleb, and then you can celebrate May 4th with joy.
Yeah.
We also have like the new Lego Star Wars game that came out about a week or so ago. So that helps.
Yeah, but more importantly, we have the Obi-Wan Kenobi show coming out in the next month.
Oh,
Love
wow.
Ian McGregor.
I have been under a rock, I feel.
yeah.
How did I not know about that?
Oh, you're under a rock? I haven't seen any of the new Star Wars movies, so
Oh,
you're
they're
fine.
That's
so
fair.
amazing. I love The Mandalorian and the Book of Boba Fett and like the Clone Wars Bad Batch and all that stuff.
Are you being sarcastic?
Oh no, I love it. I definitely love it. I love all the stuff that Dave Filoni's coming out with. Oh.
I wasn't quite sure there, Caleb.
Oh no, I love it. I'm a very big Star Wars fan, so.
So we got a big Harry Potter fan here, and we got a big Star Wars fan here.
Yeah.
Guilty as charged. I mean,
I mean, there's that running joke that everyone's saying that Harry Potter is a ripoff of Star Wars with magic wands. So.
Oh, well, that's not true. Come on. I mean, there's some things here and there. There's a young boy and an old man who's an old man who's his mentor. A Dark Lord.
Yeah.
But
that's something we can discuss later on. But we have a lot to discuss today and a lot of constellations. Some are very familiar friends, and some may be new to all of us. I'm very excited for this show. But as you may have noticed, our viewers who are regular, we were not on last week, but we are on this week. And so we were going to talk about some cool stuff involving the moon and the past holiday Easter. I'm going to pass the mic to Madeline and she can get us started.
Yeah, so the full moon was last Sunday, I believe.
Mm-hmm.
I can't remember because it's in the past.
Right.
But the moon happens to be very important, not just in a secular science sense, but it also happens to be important for a lot of dating of religious events. So I just wanted to give you guys a brief overview of both of those things. So do you, well, I was going to say raise your hand, but we can't see Caleb. So have either of you guys done observations with a telescope?
Yes. I have.
Same. I have too.
Well, the moon is kind of a little pesky when it comes to observations. As you guys might guess, it is one of the brightest objects in the night sky, if not the brightest. And that means that anything, because it has such a high brightness spread out over a large surface, you have it washing out a lot of things in the sky near it. It's kind of like natural light pollution in the sky, is how I like to think about it.
It doesn't just affect optical astronomy. Also, I work with the Veritas telescope, which works with gamma rays, and that even they have to take the moon into consideration during their observations. So,
wow.
Yeah, everyone has got to take the moon into their account. So we find in normal everyday life, it's useful to have the moon up because you can maybe see a little bit more at night. but it is not helpful for astronomers. It's like the bane of astronomers, especially those who particularly study fainter diffuse objects like I have. So like think of like galaxies, nebulae, supernovae.
Mm-hmm.
Um, and they because of that, they always those kinds of astronomers and honestly like stellar astronomers too. Um, sometimes they astronomers who study fainter diffuse objects, they are called night sky astronomers, or not night sky, dark sky astronomers, because they prefer to have no moon up at night. And
Understandable.
since everyone likes to have no moon up at night when they observe, my research professor at IU once said that everyone likes to be a dark sky astronomer, but not everyone necessarily needs to be a dark sky astronomer.
Right. Well, here on Constellation Crew, we have Stellarium, which is our program, or Stellarium, either is fine. And sometimes on the program, we can go forward in time or backwards in time. In this case, I'm going to go forward a couple hours to bring up our moon. It will not be a full moon. Stellarium, this is pointing north tonight at about 8 o'clock, not too long past sunset. But I'm going to fast forward, and it's going to be pretty early in the morning. And look at that.
Here we go.
There's our moon. And then you'll see some cloudy stuff here. And that's actually the Milky Way. So that is an unfamiliar picture to a lot of people who live very close to a city like Indianapolis or Chicago.
Honestly, insert any city.
Yeah. And in Stellarium, we can tweak the effects so that we can still see it in this program. But what's really cool is we can actually turn off the planets and the moon in here. So let's see if there is a difference. And keep an eye on the Milky Way here. And keep an eye on the moon over here. So let's see what happens. Little bit brighter.
It definitely would had we had the full moon up and done this
Yes.
last Friday like originally planned, it would have been a lot more dramatic.
If we have time at the end of the program today, maybe we can do that. We can go backwards we can go to BC, I think, in Stellarium. So
Yeah.
we can definitely time travel all the way back to Saturday, the night before Easter, and do that. But
Yeah, speaking of which, you guys might not know it, but the phases of the moon are actually really important in the determination of the date of Easter each year and also some other holidays like Passover and Ramadan.
oh wow.
Ooh.
So when we originally were going to do this particular program, we meant to do it last weekend because last weekend you had Easter, you had the start of Passover, and we're in the middle of the month of Ramadan. However, we weren't able to do that. So, but fear not, all of those holidays are technically more than one day. Plus, I believe Orthodox Easter is this weekend, so it's still all relevant. And I wanted to share with you guys kind of a little bit of the rabbit hole I went down last week, searching for information on how these dates are determined. You guys ready for that?
Yes.
Let's go.
So we're gonna start off with Passover because this kind of like sets the foundation. And in Jewish calendars, the days, especially back in ancient times, the days were considered to begin and end at sundown. And so, like, for example, sundown on Friday would mean you would transition over to Saturday and so forth. So in the Jewish calendar, Passover actually begins on a fixed date, and that date is 15 Nisan. But unfortunately, the Jewish calendar is what's called a luni-solar calendar, where the months are based on lunar months, but the years on solar years. So that means that the Gregorian calendar, which is a solar calendar and the one that we use throughout the world for the most part,
Mm.
it means that Passover never starts on the same day on the um
Oh.
every year on the Gregorian calendar.
Oh, well, that makes sense because the full moon doesn't happen on the same day of the month every month and
Yeah.
Yeah.
from year to year as well. So that makes sense.
And what
Yeah.
makes
I
things
mean,
so you have these 12 lunar months in the Jewish calendar, which are alternating 29 or 30 days.
Hmm.
And new lunar months were heralded by a new moon. However, um, this is only, depending on the year, this is only 353 to 355 days per year, which we all know that a solar year is closer to 365 days.
Hmm.
yeah.
So, as a consequence, there are 7 years within a 19-year cycle with the Jewish calendar where they add in a leap month of 30 days to compensate for that.
Oh, I like that.
I believe I read like in more of my classes that like in the previous history, I think around the time of the 1500s, there was a real big problem with the calendar. I mean, they had like certain dates were happening even a month later than they normally would be.
Yeah,
So
which is actually what I was just about to get into. So we set the ground with the Jewish calendar and the calculation of Passover. And so you Passover tended to happen around the full moon of the Jewish month of Nisan. So, fast forward to about 2000 years ago, um, when Easter first started becoming celebrated as a Christian holiday, it was originally very firmly tied to the dates of Passover because if you look in the Bible, Jesus ends up getting crucified on the preparation day for Passover, which many of Christians around the world refer to that as Good Friday, which
Oh,
last week would have been Good Friday for most of Western Christianity.
yeah.
So, as a consequence, Jesus gets crucified on the Friday of Passover, and then when you read the Bible, he rises on Sunday, and that would have been Sunday of the Passover week. However, and actually, you can see how the tie between Easter and Passover because in most languages around especially in the European languages, you have the word for Passover is related to the Latin root word Paschal,
Oh.
which is derived from a very similar etymologically word in the Hebrew language, which I'm not going to try and pronounce because I don't know Hebrew. But the English word for it is a little bit weird, where it's derived from an Old English goddess of the dawn, which I think is kind of fitting because it's kind of also an astronomical event, like the astronomical events used to date these religious holidays, but also it's dawning of a new era. So,
Yeah.
in any case, Caleb hinted at this, and um, starting in about the third or fourth century AD, you had some dissatisfaction with the Jewish calendar. Um, there were a lot of peeps out there who didn't like what they perceived as the disorderly state of the Jewish calendar. It felt a little bit like haphazard inserting in those leap months
Hmm.
because they were starting to notice that Easter sometimes would end up before the vernal equinox or the start of spring, and they were like, well, Easter is supposed to be this kind of, spring religious holiday, and we don't want it to happen during winter.
Right.
So eventually, we have the creation of this new calendar called the Gregorian calendar by Pope Gregory, and I forget which number Gregory he was, but because there were a few. But yeah, there it's a running joke that there are certain popes that there's multiple of the same name, and so you can easily like name uh like 15 popes with one name. But in any case, um at that point, the Western world was using what's called the Julian calendar, which is very, very similar to the Gregorian calendar, which they was developed as a refinement of the Julian calendar. And so the Julian calendar, its main problem was it tended to overestimate the length of the year. And so Pope Gregory and his friends, they refined it by making our current system of leap years, where we have a leap year every 4 years, except for years that are divisible by 100, unless they're also divisible by 400 and stuff like that. And so with this refinement, you have the Julian calendar and the Gregorian calendar off by about 13 days. And so how this kind of like leads into the calculation of the date of Easter is that there's a little bit more nuance than this, but it generally tends to fall on the Sunday after the first full moon of the vernal equinox. And so this is why you had Easter being last Sunday for most Western Christians. And then my Orthodox friends out there, they typically still use the uncorrected Julian calendar, which leads to, in most years, the date of Easter being about a week after the date of Western Easter. So that's a little Spark Notes version of what I learned last week. So we've got Passover, we've got Easter, and then you got Ramadan, which is for this year basically the entire month of April, roughly. And like our Jewish friends, the Muslims have an Islamic calendar. And similar to the Jewish calendar, you have a lunar calendar. They use a lunar calendar, but their calendar is strictly lunar, not lunisolar. And so because of this, they have a 354, 355 day calendar. But instead of the a new month being heralded by a new moon, you have a new month being heralded by a crescent moon, which if you think about a lot of the flags of Muslim majority countries, you have that like crescent moon shape on their flags, which I guess kind of like makes sense now.
Oh, I love crescent moons. They're so pretty. Full moon is great.
Yeah.
Waxing and waning phases are also beautiful. The crescent moon, cuz me as a child, I looked up at the sky once when I was 5 and I said, "Mom, look, there's a toenail in the sky." And she just
Yeah. So if you thought if you agreed with our ancient friends who reformed the Julian calendar and that the Jewish calendar was a little chaotic, it gets a little bit chaotic with the Islamic calendar as well. And it's because that the sighting of the using the crescent moon to herald a new calendar, while it's common across many parts of the Islamic world, it is not universally the thing that they do. And so because of that, they tend to only use the Islamic calendar for religious purposes. and the Gregorian calendar for other purposes.
Mm-hmm.
And so in the Islamic calendar, Ramadan is the ninth month of that calendar,
Mm-hmm.
and it commemorates for those who don't know, the first revelations of the Prophet Muhammad. And
Oh.
so once they cite using the crescent moon as their thing, they use that to date the start of Ramadan. And because we have uh this Islamic lunar calendar, much like the with Passover, the start of Ramadan is never fixed relative to the Gregorian calendar, is only fixed in the Islamic calendar.
Mm-hmm.
And so as a consequence, and the fact that the calendar is purely lunar and they don't tend to correct it, you can almost have Ramadan in any month of the year.
Oh.
And it's mostly in July
Mm-hmm.
and or in June, but sometimes you get it shifted as far back as April and May. And
I am actually curious about this. So like you said, there's Ramadan happens in the ninth month of the lunar calendar. How many months are there in the Islamic calendar?
I believe there's 12,
All right.
Oh.
but it's been about a week since I did my research, so I'm not entirely certain about that.
Mhm.
But I would presume it's the ninth month out of 12,
Nice.
given the similar length to the Jewish calendar, which has 12 lunar months.
Could it then be possible if Ramadan were to happen early enough in the year that there could be two of them in a single calendar year? Like say if it happened in January.
Maybe. I don't know. That would be a question for someone who is Muslim or knows more about calendars than I do.
Hmm.
But it's an interesting thought.
Yeah.
I know yeah. So these calendar things are fascinating, and if you go down the rabbit hole, it gets complicated really fast. So if people are interested in looking into this stuff more, proceed with caution given the complexity.
It's still really cool though, because I know that tons of people have had the same teacher in whatever grade level you had, and they always said, "Oh, math is everywhere. You need to know this." I also had a physics professor or teacher, both, same title, who would say, "Oh, physics is everywhere. You need to know this." But no one ever really said astronomy is everywhere. They always would say, joke around how it's a very small field, and then you actually start to get into it and you realize that it really is everywhere.
Yeah, well, I mean, a lot of like the calendars and doing like religious calendars and stuff is what motivated a lot of, among other things, it motivated a lot of ancient societies to start studying astronomy.
Mm-hmm.
Like I know explicitly for a lot of like the early Muslim civilizations, they were really, really interested in astronomy because they were like, we need to know like the dates of these, religious holidays every year. So like we need to like look up at the sky.
Right, right.
And so it's kind of cool how like in a lot of,
Well, if you think about a
different
lot of
religions, their
calendars,
religious convictions to motivate themselves to look up at the sky.
Mm-hmm.
well, if you think about it, a lot of the calendars across the world, I mean, started out from people observing the sky. I mean, if we remember, I mean, you know this better than anyone, Madeline, about our show about Celtic astronomy a few months ago. I mean, how how a lot of their calendars are based off of what they observe in the sky. So, which is very important for knowing what time say to plant crops or even harvest them. So,
Yeah, absolutely. Or if there's one thing, pick any of our favorite, ancient civilizations had in common. It's the use of astronomy and the study of astronomy for these purposes.
Right.
Mm.
Well, speaking of looking up at the night sky, this is what Constellation Crew is all about. We're going to be looking up at the night sky tonight as well. So, usually in our programs, we try to face south to give ourselves a similar direction so that we know exactly where we're pointing. But today, if you notice, we are facing north. And for our friends, what is in the north that we know of, a very popular constellation? I will scroll up to give you a hint.
It's definitely not the Little Dipper.
Could it be something to do with a bear, maybe?
A bear? A bear, there you go. Not Little Dipper, but the asterism, the Big Dipper here. So we're going to click on here so you can see the full constellation, which is Ursa Major. And this is one of the very few constellations that I recognize as an animal shape. Granted, it's upside down at the moment. But I kind of see the bear. If you twist your head around enough, I can see the bear and the long tail.
Mm.
But the Big
Although
Dipper, yes?
some artist pictures have like the bear having a long tail. Like that's not how a bear looks like. A bear doesn't
Well,
have a long tail.
didn't the story go that like someone like threw Ursa
Mhm.
Major and Ursa Minor by their
Yes.
tails into the heavens?
Yes, and this story can get pretty confusing because the mother bear, or rather the big bear and the little bear, have different characters and different myths associated with them. And in fact, what's really funny is one of the myths has to do with one of the many sons of Zeus. But he is
Like
actually
many.
more associated with the constellation Boötes. And we're going to use Ursa Major to find Boötes today. So we're going to take the little star here at the end of the handle, and we're going to draw sort of a straight line, kind of diagonal, but it's straight towards a very bright star. If you follow the mouse, it's this big star here. If we click on it, this is,
Arcturus.
yes, Arcturus. And here is Boötes here. But even though we've talked about Boötes before, that is not the constellation we are going to talk about in depth today. So we're going to use this big star here, Arcturus, again, and draw another straight line to another constellation, connect the dots. And this is a little bit more straight than the last time. And we're going to be here with Virgo the Maiden.
In fairness, it's follow the arc to Arcturus and the spike to Spica. So.
Yes, it is. Thank you.
Nice. That's very nice.
So it's not your fault. It's not a straight line for
Yeah.
to go to Arcturus.
This arc does, yes, like Madeline mentioned, has a very special name. It's a very common arc to use to find these constellations, which is kind of cool. I didn't even know that kind of stuff existed, but that's the best part about learning, is that you learn something new every day. Virgo is going to be in the southeastern sky, but my friend Caleb has a lot to talk about with Virgo today, so I will pass the mic to Caleb.
Well, okay. Virgo, I mean, as some of you might have heard this conversation before, is actually one of the members of the zodiac constellations.
Yes.
So
I think it is.
Yes, it is.
So shout
It's
out to
like
anybody
later
out.
in the year.
So shout out there to anybody who's Virgo. So
Nice.
so as we all know, the zodiac. I mean, are all constellations that are traced by what we call the ecliptic, which is the path the sun takes throughout the sky during the year.
Yes.
So
Yeah. Me and Dr. Vaccaro, a couple of weeks ago, we were sitting in the conference room and talking about the precession of equinoxes and stuff through the ecliptic, and we were talking about how, like, as a result of that, you have over the course of thousands of years, you have the constellations of the zodiac appear up high in the night sky in different months. So that was fun.
yeah, and in astronomy we also use we also use one of the constellations of the zodiac as like our kind of like our map of the heavens. I mean, I believe it's the one that's the goat, the ram,
Aries.
Aries. I mean that it's the symbol for that constellation is used as a in astronomy as our kind of our one of our guide maps for the heavens. So
See, you said goat, and I got really excited because my um astrology sign is Capricorn, which is the goat fish. So you said goat, and I got really excited.
Did you
And
just say goatfish?
yeah, goat fish.
yeah, he's got like the front of a goat and the back half of a fish.
He's a goat mermaid. Yeah.
Okay, after this, I'm gonna look up what Capricorn is, the technical term for a goatfish is, because
Yeah.
I honestly don't know, and I feel like there is one.
there should be.
Let's get back to Virgo.
Right.
Yeah.
Virgo has
Virgo's
a
the
couple
star
of
of the show here.
Virgo has a couple of interesting things in it.
Ooh.
One of which is a globular cluster known as NGC 5466.
What a
I believe-
creative name.
Yeah, I mean, like if astronomers gave every object they found in the sky a name, that's based off like the Greek or Roman times, we'd run out of names. There's only so many stories. So
Yeah. For those of you who don't know, NGC is an acronym for an astronomical catalog. I think the New General Catalog is what that stands for.
yeah,
But I'd have to go back and look at my notes from years ago.
yeah.
I have it pictured here in Stellarium. For some reason, it's right above Boötes, so I wonder if it's more of a Boötes object.
Depends on where you'd have to look at the constellation boundaries.
Yeah, thank
This-
you, Madeline.
So this object is what's known as a globular cluster, and there in astronomy we know of two different kinds of clusters. One of which is known as an open cluster, and one of which is known as a globular cluster. Open clusters are stars that are not as gravitationally bound to each other, whereas globular clusters are very gravitationally bound, usually clustered very tightly together. I mean, granted, this is a very big area, but if you actually notice it's actually noticed this globular cluster is not as actually tightly bundled together as other ones are. So a lot of the stars are not very concentrated towards the center. So
Yeah, it kind of reminds me of like a city where you have a
Yeah.
lot of people like crammed into, however many like square miles. So globular
And-
clusters are the cities.
yep. And they were very old cities because actually they're some of the oldest objects, not just in our galaxy, but also in our own universe.
Wow.
So
How old is this one?
this one is about 13.7 billion years old. That's an estimate right there. So it's almost as old as the age of the universe itself, which most astronomers estimate to be around 14 billion years. So
Wow.
It's pretty dope.
It-
so
It's a big number.
so
Wow. I also love that astronomy names go one of two ways. It either makes sense or you wonder. And in this case, I don't know if our viewers can see it. When we click on things and we use the technical name, sometimes in the upper left of the screen, it'll tell you a popular name that it also goes by. And in this case, this cluster goes by the snow globe cluster or the ghost globular cluster. I like snow globe, even though it's about to be spring/summer, or it's spring now.
I hear the word
Nicolette,
ghost.
we were both born in the winter. We can appreciate
Yes.
it's snow
I
globe.
hear the word ghost. I think like the wolf of the Jon Snow in Game of Thrones.
Yeah.
Oh my- we're just getting all the pop culture references in here today, just like
Oh.
always.
Yeah. I am like a nerd, so like I will come up with stuff that somehow has connection, seemingly has connection to something else that is in pop culture. So
Maybe Star Wars and Game of Thrones can sponsor us since we mentioned both of them in this program.
I would take any opportunity to meet George Lucas. I mean, like,
Right.
and Dave Filoni. Love the both of them. But actually, this cluster is not the only object we can find in Virgo. There's actually a pretty famous object that we know of as the Virgo Cluster. So, well, let's
what kind of cluster is it if it's not an open or a globular cluster?
Well, this is a cluster actually something a bit bigger than a globular cluster. These are actually clusters not just stars, but actual galaxies. So we often think of galaxies, we think of our own home galaxy, you know, like Milky Way, which galaxies as a basic definition are like areas where there's like, you know, a bunch of stars, gas, and dust. I mean, you know, a lot of it, you know. Where and then if we go on the bigger scale, we get to what, you know, we call groups or even clusters of galaxies. And the Virgo cluster is actually a cluster of different galaxies, which, you know, contains over 1,000 galaxies. You know,
that's a lot of galaxies.
Oh yeah,
that makes me happy.
And they're all bound to each other by their own gravity. And you know, even though it's called the Virgo cluster, it's actually part of a bigger group of, you know, this is where we get to the very bizarre, because we get what's called a supercluster. Supercluster, which is actually called
those names.
It's actually called the Virgo supercluster, which our own galaxy and our own local group is a part of. So we're actually still, you know, so we're just in a different part of the supercluster that we live in. So.
Wow. Interestingly enough, I looked it up, as you guys noticed, and it directly pointed me to this pinwheel here, and I said, wait, I want more than that. Why are we getting one? And then I zoomed out and look at all the little wisps, the spirals, and it's so cute. I love how they're scattered about everywhere.
Actually, I was looking at this area of the sky at Stellarium last week, and I actually found what's known as the Marcarian Chain, which I think is pretty close by in the sky.
Oh,
what's the Marcarian Chain again?
This guy? Looks
it's actually, you know, a group of galaxies themselves. You know, so
that might be it right here. It's just so cool. So for our viewers here, if you ever are looking up at the night sky with binoculars or a telescope or a really fancy observatory, if you're really lucky, and you see a smudge, that's most likely not a star and something else. So maybe a nebulae, a galaxy of some sort, especially if it has some sort of a spiral shape or elliptical shape, because if I zoom back in, maybe at the right spot if I'm lucky.
Well,
or not.
This taking a trip down memory lane for all three of us. I mean, remember last semester with good old Mr. Barrington's class, we observed you know, the Andromeda galaxy through a telescope, and you know, even with a telescope, it looked nothing like it does in pictures. They get big.
I believe in an episode last semester, I showed the picture that Nicolette and I took our night we had to go observe.
Yeah.
Oh man, that night was brutal for me and my partner.
Oh, the clouds, yeah.
Yeah. You and Cal didn't have great luck that night.
Oh, we did not. Oh, we didn't get done at least till 2 a.m. Oof.
See, wow. I feel like all of the observing runs for that project were kind of like Constellation crew, where there was at least one gaffe during each observing session.
Also, we were also getting to the time of the year where the weather is not so great. So you're getting to the lovely, you know, wintry era of Indiana.
Yeah. Well, crew, we're starting to run out of time here. We still have a couple minutes left, but we're going to go back to Ursa Major here, and we're going to point out 2 more constellations, and these are kind of important because there's an event going on, and I love pointing these out because I never got to experience them as a kid, and now I find them very fascinating. But before we talk about that, we're going to go back to our handy-dandy little star at the end of the handle here. I'm going to do my best to pronounce it. If you guys can see it in the upper left, be my guest. But I'll just call it at the end of the Big Dipper here, the little handle. We're going to draw a line towards the horizon sort of straight, and you'll notice it's a really bright star. Very bright star. This is the star Vega for Lyra the Harp. So we have Lyra the Harp, which is important, and then we're going to go back to our handle here again, and we're going to draw more towards the east this time until we find a trapezoidal shape kind of thing. And that is a part of Hercules. If you find the trapezoid, then you're pretty much there, because some of these arms and legs here, I don't know if I'd be able to pick those out in a dark night. But
Yeah, it's difficult
yeah, but
to
if you
say
get,
the least if you don't have like a star app.
yes. But very briefly, Madeline is going to talk about what is going on here, and I'm going to pull it up.
Yeah, so what's important here is actually there is it I guess it was perfect that we ended up for there's a meteor shower that peaks tonight. So even though most of our other stuff was dated for last week, it's actually perfect for the Lyrid meteor shower. And it is actually one of the oldest meteor showers ever recorded. I read somewhere that it was seen by the Chinese almost 2,500 years ago, and
Wow.
that's quite a long time away.
Yeah.
The Lyrid meteor shower happens around April 14th to April 30th every year, and we are lucky that tonight is the peak. So if it happens to not be cloudy and you go out into a sufficiently dark place and you're up for a challenge, you can try and view this meteor shower.
Yes.
Now, word of warning, it will be difficult to spot because Lyra is close to the horizon right now, and there are, at its peak, you're only going to get about 18 meters per hour, which you might think that's a lot, but if you compare it to the more famous Perseid meteor shower, the Perseids have a rate of about 90 meters per hour. Also, you're going to have to either stay up really late or really get up really early. But if you take yourself to a dark place and let your eyes adjust for about 15 to 20 minutes before you observe your meteors, I challenge you to try and go do it. Because well, it is only through challenges that we become stronger, better human beings.
There you go. I like
I
that.
think that's in a post. I think that's in a poster somewhere.
Quote me now. Just
All right. Well, we have enough time to do a couple more objects in near these constellations, and then we are students first, and we do have classes this morning. So, Caleb, are there any fun objects near Hercules or Lyra that we would like to look at today?
In fact, there are
Cool.
actually. There's actually one by in Hercules. That's actually by what we call the asterism known as the keystone. That big kind of trapezoid shape we talked about before Hercules. Along one, I think it's on the northern line, the upper line. We see what's called the Hercules Globular Cluster, or it's often called the Great Hercules Cluster, I think. So.
Let's. Oh yeah, there we go.
So
Oh wow!
Right on that, right on the line. So this is like NGC 5466 is actually another globular cluster, which is in the Messier catalog as M13.
Wow.
This is actually a globular cluster that's actually pretty fair. I mean, well, kind of close to us. It's about 22,000 light years away. And this contains a lot more stars on the order of like hundreds of thousands. And actually a bit of astronomy history with this thing. Actually, some people might have heard of the radio telescope known as Arecibo. They actually sent a message to the cluster containing information about Earth, like about our world, about pop culture, images and like sounds from Earth. You know, it has a message. They sent it to Globe Cluster.
Oh.
Unfortunately, they didn't. It was premature because the fact is, by the time the message will even reach that point, the cluster will moved out of the way.
Oh.
Of where the message is headed. So it will just keep going, and maybe one day it might hit something. So, so unfortunately, it's a message that they sent, but unfortunately, likely no one will hear it. So,
Oh. It's so sad. Well,
so,
we tried.
but
That's
actually,
the
there's
effort.
another object that's actually right south of the star Vega. This is a much more, I guess, it's a much more fun object. It's a much more, I guess, pleasing object because it's so colorful. It's known as the Ring Nebula.
Ooh, I like rings.
So,
As you have at least one on your hand, I'm pretty sure, Nicolette.
Yes.
yeah.
My sister gave
So,
it to me. It has the Big Dipper on it, coincidentally.
That's
yeah.
very on brand of you.
Whoa, why is that so blurry? There we go.
So this is the Ring Nebula. Some of you might have seen pictures of this before, but it's a planetary nebula, which was made by a relatively smaller mass star, like similar to our sun, which ended its life. I mean, over 1,500 years ago. So
Wow, it's beautiful.
so this is and actually if you see that the cloud that all that hazy stuff, that's actually the cloud of gas of the star pushing away its outer layers, and actually is actually expanding. Not by a relatively noticeable amount. It actually it's actually expanding by a rate of 1 arc second per century. So in astronomy, we use in the sky, when going throughout the sky, we use like a system like where we use like degrees, and then arc minutes and arc seconds. So it's kind of similar to like how we use like do like time in like time. So like say 60 seconds is a minute and 60 minutes is an hour. So you can think of it something similar to that.
Interesting.
So eventually there might come a point where we won't even be able to see it anymore because the gas will be so far away that it can't be lit up by the white dwarf inside. So
wow.
Guess we can't have all the beautiful things in the world forever.
actually, I know this is a topic, but actually, there actually will come a point where we can't even see solar or lunar eclipses anymore. So because the moon is slowly moving away from the Earth, so eventually at that point we won't be able to enjoy that anymore. So
the more precise thing is like specifically we won't be able to see total solar eclipses anymore. We'll still for a long time after we can't see total solar eclipses anymore, we'll be able to see annular eclipses, which are kind of like total solar eclipses, except
yeah, but it's not the same. Like like that. I weep for the day that will happen.
Well, Caleb, fortunately for you and me and Nicolette, it won't happen in our lifetime.
Yeah, that's good. Yeah.
Okay. Well, friends, sadly, we do have to end the show, but are there any final regards that you guys would like to share?
Just keep looking up, people. There's some, even in these light polluted skies, there's still a lot to look forward to when you look up.
Yes, I would agree.
And if you see something that looks like a moon, it might not be a moon. It might be a space station that can destroy planets with a single blast.
For the reference, he's talking about a Death Star. There is no craziness out in space that would actually do that. It's just the Death Star in Star Wars.
That would be honestly, that would be scary. Honestly, you don't think about like it'd be so scary, to be on a planet and then like the Death Star shows like, oh no.
Hey, at least At least that's in a galaxy far, far away and
A long
not
time
in
ago in a
ours.
galaxy far, far away. Oh,
Yeah. Well, thank you guys so much for watching. We appreciate all of you. If you would like to learn more about the Brown Planetarium or would like to visit, feel free to look at our social medias and our website. And I hope you guys have a wonderful day, and definitely look up and take a look at our constellations that we talked about today. Bye, guys.
bye.
Bye.